Today we're going to start looking at logs. So the first question is probably, what is a log or a logarithm? And so if we let b and y be positive numbers with b not equal to 1, the logarithm of y with base b is denoted as log base b of y. Now it is important that when we write our logs, if you remember like back in the day when you had paper, we want to make sure that we write log and our base goes down here, and then whatever's on the inside goes in line with our log. I'm going to make sure that's very clear what the base is. So log base b of y equals x if and only if b to the x is y. And so we can convert a log into an exponential by doing sort of the circle b to the x equals y. And so what a log does is it asks a question, all right, base to what power equals inside. Let's take a second to just practice going back and forth between our log form and our exponential form. And because we can do this, these are inverses of each other. And so we need a log because a log is going to undoes a base, like b to the x. So if we need to know what x is and we gotta get rid of the base, we're gonna use a log. So let's go back and forth. So if we know log base 2 of 8 is equal to 3, and if we use our little circle, this is asking 2, or it's saying 2 to the third is equal to 8. And we know that's true. And so in B, we want to get the log. So remember, this is our base, and it's our base over here, right? The base of our exponentials. So this log is going to be base 4. Log, I'm going to make sure that 4 goes down. Log base 4 of 1 equals 0. And so if you notice, our log is equal to the exponent. So in our next one, we've got log base 12, because that's our base over here. Log base 12 of 12 is equal to 1, the exponent. Here we're going the other way. We've got a log. Base stays base. This is log base 1/4. So 1/4 to the negative first power, put this in parentheses, equals 4. So that's how we go back and forth. So if we want to evaluate a log, we need to ask a question. It's just like square roots. Square root of 9. We're asking what squared gives us 9. Right? Because if this equals x, then we can sort of undo it, right? And that would be square both sides. What squared gives us 9. And so we also have the addition of, we're looking for what is positive and squared gives us 9, so we're going to say 3. This is kind of similar to our square root situation. So a logarithm asks the question, base to what power equals the inside of the log. Let's look at a couple examples. So our first one, we've got log base 3 of 27. That's how we would read this. Log base 3 of 27. This is very similar to square roots. This is a square root of 9. This would be the cube root of 13. This would be the 7th root of 129. Right here we're just saying log base 3 of 27. What's the base? Well, the base is 3. What's inside the log? 27. Right? Let's color code these. We'll make this purple, make this green, So our base is down here. Our inside is going to be in parentheses. If it's not in parentheses, then it's not inside the log. For example, log base 2 of 4 plus 1. This is the log. This is on the outside. This has a base of 4 and an inside of 2. That would be different than this. Log base 2 of 4 plus 1. Here the base would be 4, but the inside would be 4 plus 1 or 5. All right, so we got to watch out for those parentheses. So if we want to know log base 3 of 27, what does that equal? What we're asking is, what is the power of 3 that is equal to 27? And so one way to write this that I kind of like is using this little question mark. So if we have log base 3 of 27, that's when we want to evaluate. Okay, so 3 to what power is 27? Well, let's say I didn't know. So let's put it in here. 3 to the something. Then let's use our table. Well, it's not 0. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. 3 cubed, there we go. 3 cubed is 27. So what I was looking for is 3. So let's do a couple more practice problems like this. So we're going to evaluate these logs. We've got log base 4 of 64. We want to know, what does that equal? So this says, what power of 4 gives us 64? Well, 4 to the 0 is 1. 4 to the first is 4. 4 squared is 16. 4 cubed is 64. So this is going to be 3. All right, we could also have done that with this table in Desmos. What power of 4? 4 to what power? Plug it in. 1, 2, 3 would give us 64. All right, let's do our next one. This one says log base 5 of 0.2. So we want to know what power of 5 is 0.2, because that's the question it asks. We can also convert this into an exponential, right? And so we're looking for what power of 5 equals 0.2. And so if you notice, 0.2 is smaller than 5. And so if we say like 5 to the 0 is 1, 5 to the first is 5, 5 squared is 25. We're going the opposite direction if we let these numbers go bigger, right? So we actually want to go smaller. So that means we need to actually go this way. So we're looking for some negative numbers. So let's put this in. 5 to what power? Let's use our table. Oh, and if I make my table, we actually already see it. Look at this. We got -1, 0.2. So this is -1. Let's talk about why that is really quickly. 5 to the negative first is 1 over 5, right? And 1 divided by 5 is 0.2. Okay. All right, next we got C. This time, our base is a fraction. Let's do it. Ask the same question. Base, 1/5, to what power gives us the inside of this log, 125. We'll notice now that 125 is much larger than our base. And our base is a fraction over here. So that indicates we got to make this fraction. If we do 1/5 to the 0, that's going to give us 1, right? If we do 1/5 to the first power, that's 1/5. This is going down. So we want to go this way again because we need to get big. So this is going to be another negative. And if you think about that, 1/5 to the negative something, that negative is going to flip it 5 to the something, right? Let's use our table. We've actually already got 1/5 from our last problem. So 1/5 to the something, use our table. And we do see as we go up, 0, 1, 2, our number actually gets smaller. As we go down, -1 is 5, -2 is 25. Let's try -3, 125. So this is going to be -3. All right, last one. So this one we've got 36, our base, 36, to what power is going to give us 6? Well, so we actually know, maybe you see very quickly that 6 squared is 36, but that's backwards, right? That's the power of 6 that gives us 36, not the power of 36 that gives us 6. And so if we can go backwards like this, then to sort of switch it, we're actually going to do 1 over 2. Or we could use our Desmos to help us. Look at this, we're going to do 36 to the x, make our table. And we see that we're here, 0 and 1. 36 to the 0 is 1. 36 squared is 36. So we need to be in the middle of this. This should be 1. And so if we, what's the middle of 1 and 0? Well, that's 1/2. And we would get 6. Sometimes it is easier to think about this backwards and then to do the 1 over to get it to both be integers. Notice if we're switching between a decimal and a whole number or a whole number and a fraction, we get a negative answer. But if we're switching between just 2 numbers, we're either going to get a whole number, we're going to get a positive whole number, or we're going to get a positive rational, like this one. Okay. So can we take the log of any number? Right? Can any number be on the inside? Well, let's try it. So here's our x, and we're going to take log base 4 of x. So this one would be log base 4 of 4. And so that means we want to know what power of 4 gives us 4. Hopefully it's pretty obvious that that's 1. 4 to the first is equal to 4. Then we've got our next one. Log base 4 of 4 equals, oh, nope. Log base 4 of 4, log base 4 of 1 equals something. So we want to know 4 to what power equals 1. And if you remember, I really emphasized this before. This is going to be 4 to the 0 power, because anything to the 0 power is 1. This gives us 0. Our next one is log base 4 of 2. What does that equal? So 4 to some power gives us 2. Well, how are 4 and 2 related? We could go backwards, right? 2 to what power is 4? Well, 2 squared is 4. But we went backwards, so we got to do 1 over. It's going to be 1/2. Our next one, we've got log base 4 of 1/4. And so we want to know 4 to what power equals 1/4. Well, if you notice, this is 4 1/4. Hopefully we're starting to see there's a 4 in the numerator and a 4 in the denominator. So if we make that a -1, that's going to move it to the denominator. So this is -1. And then if we look at this one, we've got log base 4 of 1/2. What does that equal? Well, 4 to what power equals 1/2? Well, we can sort of combine these two to give us our answer, or we could go backwards. Let's go backwards. 1/2 to what power is 4? And so we know that 2 squared is 4. We've also got to move it to the numerator. And we move it to the numerator with a negative, right? So this would be -2. But remember, this is backwards, so we're going to do -1 over 2. And so that kind of makes sense. This was 1/2 to give us a 2. 1 over was negative, -1/2. This one is -1/2. All right, let's look at this one. So we're looking at log base 4 of 0. So 4 to what power gives us 0? Well, if we multiply 4 times 4, are we ever going to get 0? No, right? The only way to get 0 is if one of these is 0. This can't happen. This does not exist. What about -1? So it'd be log base 4 of -1 equals something. So 4 to what power equals -1? Well, we're going to have to multiply 4 times other 4s to get a negative number. That's a whole bunch of positive things to get a negative thing. Can that happen? No, not possible. This also does not exist, or we might call these undefined, right? They are not allowed. And so what that means is that a log is only defined if the inside of the log is positive. Remember, positive means greater than 0. That'll be important when we talk about domain for logs. The last thing we're going to talk about is we have 2 common logs or 2 special logs. One of them is called the common log. It's called the common log because it is our natural base, which is 10. That's how we count numbers. That's how we do stuff. And when we have common log, we just leave off the base. So if there's no base, then it's an automatic 10. That's called common log. Both of these are built in to every calculator. Every calculator, so long as it has a log capability, will have the capability to a common log and our other one, which is called a natural log. Natural log is base E. That's because E, or Euler's number, right, which was approximately 2.71828182824 something, is also called a natural number. If you remember when we talked about this, I said that it comes up in a lot of natural scenarios. That's sort of where it gets its name from. And so base E is ln. This is not a 1. It is an ln. It's a lowercase l. I can't emphasize that enough. It's a lowercase l, not a 1. ln. ln of x. Natural log. It's backwards, like it's not nl because this is like in a different language. Can't remember if it's Greek or Latin, but it's like logos naturale. So it's natural log. ln. It's not a 1. ln. Okay. We're going to wrap up by doing some practice and actually looking at some logs. We're going to do some conversions, some calculations, and we're going to do a quick look at how we can put these into our calculator. Just like square roots, most of the time we use calculators to approximate these things because they're not easy to find by ourselves unless they're nice. So we look at this one, our x is inside the log, but we can get it out by using our circle notation. 9 to the negative 1/2 equals x. Well, let's resolve this. Negative means 1 over, so we got 1 over 9 to the 1/2 equals x. Then you need to remember that the 1/2 means square root. This is the square root of 9. And so that means that x is equal to 1 over 3. So here's our little circle. All right, let's go to our next one. So this time our x is in our base. It's in our base. We're going to do our circle again. Base stays base, so we have x to the negative 1/2 is equal to 7. So let's resolve this again. We got 1 over the square root of x. We just saw that happen in the last problem. Equals 7. Let's move stuff around. We got a x in the denominator. So let's multiply everything by x. When we do that, we get 1. We're actually going to multiply by the square root of x. They cancel over here, and we get 1 equals 7 root x. Then we're going to divide by 7 on both sides. And we get that the square root of x is equal to 1/7. How do we undo a square root? We square. 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 And we get x equals square a fraction by squaring the top. 1 squared is 1. 7 squared is 49. All right, let's try one that's a little bit weird. So in this one, we have log base 5 of 125 to the x. Well, let's do a little question mark over here. So we're looking for 5 to the something is equal to this, 125 to the x. So this doesn't look particularly easy to solve. And so what we want to do is figure out if we can rewrite so that these bases are the same. And 5 is 5. You can't do much with that. So this is going to stay the same. So we need to say, can we rewrite 125 as a base 5 to some exponent? Well, let's play with it. Let's go to our 5 to the something. 5 to the x. Put it in here. Make a chart. We've got 0, 1, 5, 25. If we put in 3, oh, there we go. So we know that 125 is equal to 5 cubed. So instead of 125, we've got 5 cubed to the x. Properties of exponents. 5 to the something equals 5 to the power multiply 3x. And so that means that our question mark has to be 3x. So this is going to be 3x. Now, if you're noticing, we need to remember old stuff to be able to work through these problems. We've got to actually do some thinking, be creative, and experiment. This is not going to be just plug and chug through everything. Okay? Gotta think through it. All right, let's try our next one. So here, we've got this. What is this? Is that 1n? No, it's ln, natural log. Natural log, remember, is base e. So this is really log base e of e cubed equals something. Well, let's do our circle and rewrite it. Base e to something, e to the some power, equals e cubed. Well, we have the same base, so that means that this question mark has to be 3. This is 3. And so it's basically like those cancel. And in fact, they do. Just get 3. Now let's look at our next one. Here we've got log of 1/10. There's no base here. So what does that mean it is? It means it's 10, right? That's what we said earlier. No base, automatic 10. So this is base 10. And so if we got log base 10 of 1/10 equals something. Maybe some of you are starting to see what this number is going to be. We're asking 10 to what power gives us 1/10. And we want to get to the point where we just know that this is -1. 10 to the negative first power is going to make it 1/10. Next one. All right, so we want to find log base 4 of 1. We're going to do this by thinking through it, and then I'm going to show you how to do it in Desmos. So we have log base 4 of 1. So our base to what power? 4 to the something equals 1. Well, what power always gives us 1? It's 0. 4 to the 0 is 1. So this is 0. We can actually do logs on our calculator. Desmos is nice because it does any base. If you click functions, in miscellaneous, we're going to click the second log. The first one is, this is common log. This one is, we can put in our base, log base 4 of 1. We get 0. If we put in a negative, it's going to tell us undefined. If we put in a 0, it'll also tell us undefined. All right, 3 more. Natural log of 0. Natural log. That's log base e of 0. Undefined. This has to be greater than 0. Doesn't matter what the base is. Cannot be equal to 0. It's undefined. We can check that on our calculator. Go to functions. There's a natural log button. It's above log. And if we put in 0, undefined. Our next one, we got log base 36 of 1/6. What does this equal? So we're saying 36 to what power is equal to 1/6. Well, we're going from a 36 to a 1 over. That is an indication that it's going to be negative. And so then what if we just ask the question, 36 to what power is 6? Well, how are these related? Well, 6 is the square root, right, of 36. Square root is 1/2. So put those two things together and we get negative 1/2. Let's check it using our calculator. Function, log base 36 of 1/6, negative 0.5. Click the fraction button, negative 1/2. All right, our last one. Log of negative 100. This is not log minus. Log by itself means absolutely nothing. It'd be like saying square root minus 5. Square root of what? Right? That doesn't make any sense. It has to have an inside. You can never just have a log like by itself. It has to have something inside it. So this minus is a negative sign. Don't let that trip you up. This is the log of negative 100. What's our base? I don't see a base, right? There's no base. So that means it's an automatic 10. This is really log base 10 of negative 100. And that's going to be undefined, because the inside of our log, this bit must be positive or greater than 0, and negative 100 is not greater than 0, so it's undefined. All right, so that's the beginning of our log discussion. We'll look more into logs and properties of logs in our next set of notes.